Hello students, today I am discussing one more challenging problem. It is the 8th one, and now the challenging problems will be delivered every day online from Tantray physics classes. The problem is like this. What is the force between two current carrying circular coils which are x apart or is less than x, means their radius is very less? This is the question. We have already discussed when two current carrying conductors, two conductors carrying current in the same direction, they attract each other. Same thing happens to these two coils. Two coils having current in the same sense, current flowing like this and current flowing in this coil like this. In the same sense, they will attract each other. And if the current sense is opposed, the current in this coil flows like this and this coil flows like this, then they will repel away each other. Same thing happens. But here we have to find the force. It is not that two straight wires and it was very easy to find the force. एक वायर जो है उसने मैग्नेटिक फील्ड क्रिएट किया और दूसरा वायर उस मैग्नेटिक फील्ड के इन्फ्लुएंस में आया तो हमने फोर्स निकाला. तो यहां हम ये इट्स नॉट ए करंट कैरिंग, इट्स अ सर्कुलर कॉइल, इट्स अ करंट लूप, इट्स अ कंप्लीट सर्किट, इट इज आल्सो ए कंप्लीट सर्किट. तो ये देखना पड़ेगा हाउ मच फोर्स दे एक्सर्ट ऑन ईच अदर. इफ वी फाइंड फोर्स ऑन दिस, that is enough. The same amount of force will be created on this because forces are mutual. According to Newton's law, if some force is created on this, same amount of force will be created on this in the opposite direction. So, in case they attract each other, currents are in the same sense, the force on this will be like this, and force on this will be like this. So, how to solve such a problem? How to find the force between the two current carrying coils which are put x apart? So the solution is something through steps. I will try to solve the question through steps. So here, first of all, ये देखना पड़ेगा कि ये जो coil है, it produces magnetic field on its axis, and this coil is in the magnetic field of this coil. That is all. ये जो coil है, ये इस coil के magnetic field में है. और ये खुद भी कॉइल जो ये कॉइल है ये इसके मैग्नेटिक फील्ड में है. तो वो फर्स्ट वी मस्ट अंडरस्टैंड, जब एक कॉइल मैग्नेटिक फील्ड में होगा तो उस पर फोर्स क्या है. ये कॉइल जो है ना, ये कॉइल, दिस कॉइल इज द मैग्नेटिक फील्ड ऑफ दिस कॉइल. सो फर्स्ट ऑफ ऑल वी नीड टू नो व्हाट इज द फोर्स ऑन ए कॉइल, करंट कैरिंग कॉइल इन द मैग्नेटिक फील्ड. दैट वाज अ डिफरेंट केस. इट वाज अ करंट कैरिंग कंडक्टर in the magnetic field. The current carrying conductor was a part of the circuit. It was not the full circuit, whereas this is the full circuit. So first of all, in order to solve this problem, first of all I must explain what is magnetic moment. Magnetic moment. Magnetic moment. Magnetic moment of a coil. Magnetic moment. Magnetic moment of a coil carrying current is current into area of the coil, that is pi r square. And its direction is, if the current carrying coil is like this, I is carrying current, the magnetic moment direction is this, in this direction. But the magnitude is I pi r square, and we can denote it by mu, magnetic moment. Its direction B है perpendicular to the plane of the coil, but in this way, curl your fingers in the direction of current and watch where the thumb goes. It is the magnetic field has this direction. Okay. First, second B point which I want to explain you, if a current carrying coil like this, or any complete circuit, maybe it is not a current carrying coil, it is any arbitrary circuit, complete circuit in the magnetic field, what will be the force on it? So you must remember, if a complete circuit, a current carrying coil or a complete arbitrary circuit is placed in the uniform magnetic field, the net force on that is zero. The net force on a current carrying coil, maybe this coil, maybe any other coil, the net force on a current carrying coil in the magnetic field, in the uniform magnetic field. Uniform means it has no space variation. It does not change from position to position to position. It is uniform all over the surface, all over the space. The net force on a current carrying coil in a uniform magnetic field is zero. Pehli baat to ye. But now the question is this coil in the uniform magnetic field created by this coil? This coil does not create a uniform magnetic field. ये जो कॉइल है ये यूनिफॉर्म मैग्नेटिक फील्ड में नहीं है, क्योंकि ये उस मैग्नेटिक फील्ड में है जो इस कॉइल ने प्रोड्यूस किया है. ये जो कॉइल मैग्नेटिक फील्ड प्रोड्यूस करेगा यहां पर वो यूनिफॉर्म नहीं है. दैट चेंज विद एक्स. जितना आप दूर जाओगे उतना वो मैग्नेटिक फील्ड चेंज होता जाएगा इस कॉइल की वजह से जो मैग्नेटिक फील्ड है. सो दिस कॉइल इज नॉट इन द यूनिफॉर्म मैग्नेटिक फील्ड. फर्स्ट मेक इट क्लियर. से अगर हमारे पास एक कॉइल है, करंट कैरिंग कॉइल, कंप्लीट सर्किट है, एंड वी प्लेस दैट in the non-uniform magnetic field, there is a force. There is a force. How much is that force? The force created on a coil in non-uniform magnetic field. In non-uniform magnetic field is given by कितना होता है फोर्स? एक तो ये म्यू, उस कॉइल का जो कॉइल आपने प्लेस किया है. दिस इज द म्यू. दिस म्यू इज द मैग्नेटिक मोमेंट ऑफ दिस कॉइल इनटू ओके इसका मैग्नीट्यूड dB by dx. Variation of magnetic field here at where the coil is placed, but that magnetic field belongs to this coil. That means variation of magnetic field of this coil at this point. यहां इस पॉइंट पर जो इसका मैग्नेटिक फील्ड है वो कैसे वेरी करता है विद पोजीशन, उसका डेरिवेटिव dB by dx, derivative of the magnetic field with x here. So that is the derivative of the magnetic field. Whose magnetic field? It is magnetic field? No, it's magnetic field. जिस मैग्नेटिक फील्ड में ये कॉइल है वो मैग्नेटिक फील्ड कैसे वेरी करता है विद x. ओके. डी अगर एक कॉइल है carrying current I, what is this magnetic field on the axis? इस एक्सिस पर इसका मैग्नेटिक फील्ड क्या है? But the direction of that magnetic field is yes along the axis, depending upon the sense of the current. It can be away along the axis, or it may be towards the center of the coil, away from the center of the coil or towards the center of the coil, depending upon the sense of the current. लेकिन मैग्नीट्यूड कितना है मैग्नेटिक फील्ड का? यहां इस कॉइल का मैग्नेटिक फील्ड जो है, करंट कैरिंग कॉइल का जो मैग्नेटिक फील्ड है ऑन इट्स एक्सिस, हाउ मच इज दैट? दैट इज म्यू 0 I r स्क्वायर डिवाइड बाय 2 times r स्क्वायर प्लस x स्क्वायर होल रेज टू 3/2. ये चार जो है कॉन्सेप्ट्स ये इसमें यूज होता है. ऑल द 4 कॉन्सेप्ट्स आर यूज्ड हियर इन दिस केस टू सॉल्व दिस प्रॉब्लम. Now I will give the solution of the problem. The net force on a current carrying coil placed in the uniform magnetic field is 0. But if the current carrying coil is placed in the non-uniform magnetic field, force is not 0. Force is given by this equation. And a coil, how much magnetic field it produces on the axis? That is mu 0 I r square divided by 2 times r square plus x square whole raised to 3/2. That is the base concept to solve that problem. Okay, now let me start solving the problem. Solution. पहली बात यह है कि how much is the force here? That force on this coil, that is this, that force is mu, magnetic moment of this coil which is placed here, which is in the vicinity of this magnetic field of this coil, dB by dx. That is F equal to, this is mu, magnetic moment of this coil, no sorry, magnetic moment of this coil, that's pi r square, that is area of the coil into its current, this I, d by dx. What is magnetic field produced here by this coil? इस कॉइल ने यहाँ इस कॉइल के साइड पर क्या मैग्नेटिक फील्ड प्रोड्यूस किया, दैट इज म्यू 0 I R स्क्वायर, इसका करंट, इसका रेडियस स्क्वायर डिवाइड बाय 2 टाइम्स R स्क्वायर प्लस X स्क्वायर होल रेज्ड 3/2, this one. Now F equal to pi R square I into, सारा कांस्टेंट बाहर निकालो, म्यू 0 I R स्क्वायर, यहां पर भी कांस्टेंट बाहर 2 निकालो, तो डिफरेंशिएशन किसका आगे जाकर करेंगे, किसका डिफरेंस, सिर्फ इसका, उसको ऊपर ले जाइए, ऐसे कुछ, तो इट इज F इक्वल टू, इट इज पाई, म्यू 0 पहले लिखिए, पाई I स्क्वायर R4 डिवाइड बाई 2, इसका डिफरेंशिएशन -3/2 नीचे, R स्क्वायर प्लस X स्क्वायर -5/2 -1 करके इंटू 2x, 2 gets cancelled. So what should I write? F equal to mu 0 pi I square R4 by 2 -3 into x ऊपर नीचे R square plus x square whole raised to 5/2. Now x is quite larger than R, that we have already mentioned. ये जो x है बहुत ज्यादा है, R बहुत कम है, R बहुत कम होगा तभी तो मैग्नेटिक फील्ड जो यहाँ है इस कॉइल के ऊपर, सारे कॉइल के ऊपर उतना ही मैग्नेटिक फील्ड होगा, वो तभी हो सकता है जब ये कॉइल छोटा हो, रेडियस जिसका कम हो. तो व्हाट शुड आई राइट नाउ? सो F इक्वल टू -3/2, ये वाला इधर लाया, म्यू 0 ये वाला, पाई, ठीक, I स्क्वायर R4, ये x ऊपर नीचे, ये R खत्म, x स्क्वायर का 5/2 हो गया x5, because R will go in comparison to x square, R will be neglected. So it is F equal to -3/2 mu 0 pi I square R4 by x4. This is the answer to the problem. Mark it well. This is the 8th problem, challenging one, but now I'll be delivering lectures on challenging problems every day, so keep on watching. Thank you.